Hi, welcome to this IB Maths Intense session number 2 on sequences and series, this time looking specifically at arithmetic sequences, which we found in the syllabus as SL 1.2. Part of SL 1.2 was dealing with arithmetic sequences and series. We'll come on to series in the next video, but this lesson will look specifically at sequences. So what is an arithmetic sequence? Well, all the examples on the screen in front of you right now are examples of arithmetic sequences. They all share the same characteristic, and that is that they all have in their sequence a constant difference or a common difference between each term. So in the first one, the difference is always 2. The sequence is going up in steps of 2 every time. The second one, the difference is it's going down by 5, so there's a common difference of -5. The third one, the common difference here is 0.1. It's going up in steps of 0.1. And the third one, the common difference is 3. So any sequence that is going up in constant steps or constant differences shares a common difference is an arithmetic sequence. So the next challenge we have is, how do we go about finding the nth term rule, the rule for that sequence? And we looked at a number of methods of finding rules or defining rules in the previous video. Well, let's take a look at that last arithmetic sequence, 5, 8, 11, 14, 17. And let's just have a look at what's going on here and see if we can derive the rule. So you can see each time this sequence is going up by a constant or common difference of +3, which is the difference. Each time it's going up by the difference of 3. So if we look at the second term, u2 is equal to the first term, which was 5 plus 3, or the difference. So u2 is equal to u1 plus d. And if we look at the third term, let's see what's happening here. u3 is also equal to the first term plus, this time, 2 lots of the difference. And the fourth term is the first term, 5, but this time with 3 lots of the difference added to get to 14. And I think you can probably see the pattern now, that if I was looking for the nth term then, you can see that it will always be equal to the first term plus, well, not n lots of the difference, but n minus 1 lots of the difference, because look, on the fourth term we added 3 lots of the difference. So if we're looking for the nth term, we will be adding n minus 1 lots of the difference. So let's just test that out. So our fifth term, u5, is equal to the first term, which is 5, plus n minus 1, that's 4 lots of the difference, and the difference is 3. 5 plus 12 equals 17. Tick. So we've defined there a nice formula for the nth term of an arithmetic sequence, and sure enough, there it is. So on your formula sheet you will see the lovely nth term of an arithmetic sequence defined there, un equals u1 plus n minus 1d. So you don't have to learn it, it's there on the formula sheet for you. Let's have a quick look then in the remainder of the video at just some example questions that we might get using this formula. Some of them will be straightforward, like these 3 that I've put on this slide, which is just find the general formula. And we can do these in exactly the same way as we just did that previous example. We know our general formula here for the first one. Un is going to be u1, the first term, 20 plus n minus 1 times the common difference, which in this case is 10. So I'm going to end up with a formula here that u equals 20 plus 10n minus 10, if I expand all of that out, which gives me the formula 10n plus 10. And we can test that out. Fourth term would be 10 times 4, 40, plus 10, which is 50. That works nicely. The second one, let's do the same thing. Un is going to be equal to the first term, 10, plus n minus 1 times the difference, which this time is minus 9. Be careful when it's a descending sequence. If we expand that out, we get 10 minus 9n plus 9, because it's minus 9 times plus 1, minus 1 gives a positive, and that gives us 19 minus 9n. And let's just check that out. Let's say the second term, 19 minus 2 times 9 is 18. 19 minus 18 is 1. So that seems to be the correct formula. And then some fractions in the third one. Un equals, so our first term is a half plus n minus 1. And this is going up in steps of a quarter. So a quarter n minus 1. If I expand that out, equals a half plus a quarter n minus a quarter, which simplifies to half minus quarter is a quarter plus a quarter n. And sure enough, if I look for the third term, a quarter plus 3 times a quarter, so a quarter plus 3 quarters is indeed 1. So we've found our 3 formulae. Now that's at its most simple, just finding the general formula. But we will often be given questions where we're given the formula or more detail, and we're expected to find specific terms, or we're expected to work backwards. So let's have a look at just 2 or 3 examples. Nice straightforward one. What's the 30th term of an arithmetic sequence where U1, the first term, is 250 and D, the common difference, is minus 4? Easy, just plug in the numbers into the formula. Write down what you know. U30 is going to be the first term, 250, plus n minus 1. Well, n is 30, so n minus 1 will be 29, and the difference is minus 4. So if I work that out, 250 minus 116, is it? Yeah, it comes to 134. That will be the 30th term in the sequence. Arithmetic sequence has first term 15, common difference of 6, so we know U1 equals 15, we know D equals 6. This time we want to find which term in the sequence has a value of 309. So we don't want to find UN, we want to find N in this case. So let's write down what we know. We know the term is 309, and we know that we got that by doing U1, which is 15, plus n minus 1 times 6. So this time working backwards to find the value of n. Let's just write that out. 309 equals 15 plus 6n minus 6. So I'd end up with 9 plus 6n. Rearranging that, I end up with 6n equals 300. So the solution's nice and easy. N is equal to 50. So 309 is the 50th term in the sequence. No great problem with these kind of questions. Just write down what you know and rearrange the formula to find the thing that you don't know. In this case, we wanted to find the value of n. But it could have been a question where we were given the number of terms in the first term, but we wanted to find D, the common difference. Doesn't matter. You can do that just by rearranging the formula. This time we're asked how many terms in the sequence are less than 1,000 when we've got an arithmetic sequence with the first 2 terms of 10 and 17. So all I'm going to do here is write down what I know again. U1 is equal to 10. Common difference is 7. And how many terms are less than 1,000? Well, I'm going to find out what would the value of n be when un equals 1,000, and that should tell me at what point the terms in the sequence go over 1,000. So I'm going to say that un 1,000 equals 10, which is my u1, plus n minus 1, I don't know what n is, I'm trying to find it, times the common difference of 7. Let's rewrite that, expanding it out. 1,000 equals 10 plus 7n minus 7, so it's going to be 7n plus 3. When I rearrange that, that means 7n is equal to 997. If I work that out on my calculator, n comes to 142.43. So the point at which values go over 1,000 is between the 142nd and 143rd term. So there must be 142 terms less than 1,000 in this question. The last question I wanted to show you is just to show you that often we get questions which require us to work things out using simultaneous equations. So here I'm told the 10th term of an arithmetic sequence is 93 and the 15th term is 133. So I don't know anything apart from the actual values of the terms. So I'm going to have to use simultaneous equations, and this will crop up in lots of questions for arithmetic sequences. And then when I've got my answer, I need to find the value of the 50th term. So I'm going to write down what I know. I know that the 10th term, U10, is 93, and I will have got that by going U1 plus 9 lots of the difference equals 93. And the 15th term, I will have done U1 plus 14D, that's 14 lots of the difference, gave me the result of 133. And hopefully you can see there's an opportunity there to find the value of D. 5D, simultaneous equations here, subtract the first from the second. 14D minus 9D is 5D. The U1s have cancelled each other out there. Is equal to 40, so D must be equal to 8. So I'm nearly there. If D is equal to 8, well, what else do we know? U1 plus 9D, that's 72, 9 times 8, equals 93. So my first term, U1, must equal 21. 93 subtract 72. Now I've got my two values, I can use the formula. U50, the 50th term, is the first term, 21, plus n minus 1, that's 49, times the common difference, which is 8. So 21 plus 8 lots of 49, work that out in your calculator, equals 413. So we could do lots and lots and lots more questions, but they all rely on you being able to manipulate that formula. You will either be asked to find the value of un, you might be asked to work backwards to find the first term, you might be asked to work backwards to find the value of n, you might be working backwards to find the value of d, you might be given two pieces of information, like this particular question, and use the two in a pair of simultaneous equations to find the value of both u1 and d. Either way, look at the formula, write down what you know, and then go from there. But keep practicing with the use of that nth term rule, and that should allow you to access most of the questions on arithmetic sequences. I hope you found that useful. As a starting point, we'll do some more on arithmetic series next, but thank you for watching. Don't forget to like this video and subscribe to my YouTube channel, IB Maths Intense. Tell your friends I'm here. Drop me an email if you've got any queries, requests, spotted any mistakes on ibmathsintense@gmail.com. Thanks for listening, and enjoy your maths and take care.